Hello everyone, welcome to today's webinar, Removing Undifferentiated Heavy Lifting, Optimize Jenkins Build Farms. Before we get started, I have a few housekeeping items. On the right side of your screen, you will see a Q&A window. Please use this to submit your questions for our presenter and moderators at any time. At the conclusion of today's presentation, there will be several poll questions preceding the live Q&A. Please take a quick minute to provide us with your feedback when you see these poll questions appear on your screen. Today's session is being recorded, and in the next few days we will send you a follow-up email with the links to the presentation deck and the webinar recording. And again, welcome to today's webinar, Remove Undifferentiated Heavy Lifting, Optimize Jenkins Build Farms. Our presenter today is Aaron McGill, who is a solutions architect here with AWS. We also have several moderators standing by to answer your questions. Aaron, welcome. The floor is now yours.
Thank you, Ryan. Hello, good morning, good afternoon, and good evening, depending on where you're joining us from. Welcome to the Removing Undifferentiated Heavy Lifting from Jenkins. I'm Aaron McGill, and I'm a solutions architect on the partner team here at AWS. I focus on DevOps tools and automation, so I help customers and partners make technical decisions on how to use AWS with their products and services. I'm happy to have you here with me today, so let's dive in. So software and software development is moving faster today than it ever has before. And to get a little perspective on it, let's look at what the software development cycle used to be. It wasn't that long ago before the continuous integration and continuous development or deployment methodology, also known as the CI/CD process, really became a standard. Before it became a standard, the development cycle for a new feature took a considerable amount of time. Often development teams followed what was called a waterfall methodology of development. So this was a non-iterative, sequential development process, and each phase of that process had to be completed fully before the next phase could begin. So there's a dependency of current stage on the previous stages, and often there was no working software until late in the project life cycle. So developers on a team, they may work in isolation for a long period of time, and they would only commit their code changes back to the code repository once their work on a new feature really was completed or close to the end. So this batch process not only made merging accumulated code changes difficult and time-consuming, but it also made merging the test logic difficult. So this, compounded with small bugs that accumulate for a long period of time without correction, really made it harder to deliver updates and new features to customers quickly. With the continuous integration and deployment process, developers can iterate quickly and safely release new features and bug fixes for their applications. So having a CI/CD practice really reduces the risk with smaller code pushes and automated testing, and it helps really deliver value to customers faster and safer. With the ability to move faster, companies are able to be more agile in their development cycles, and it really helps them succeed in winning their market. Getting feedback from customers faster really helps you deliver new features that customers love quicker and iterate more quickly on those changes so that you can increase the amount of features that you're able to push out to your customers. So this slide shows AWS's pace of innovation throughout the years. So at AWS, we really are driven by customer feedback. We take that feedback and we turn it into new features and services that customers want. AWS has been innovating at a rapid pace on behalf of our customers, and we've been continually expanding our services to support virtually any workload. And we now have more than 90 services that range from compute and storage, networking, database services, security, hybrid, and enterprise applications, amongst many others. So in 2016, AWS launched over 1,000 new features and services. That works out to be around 2 to 3 new features and services a day. So AWS is really a customer-driven organization. The roadmap for these features and services is 90 to 95% driven by what customers like you say is important to them. So we are really interested in your feedback to help us deliver new features and services that will help you and your companies be successful. The way that we can increase our speed of innovation and time to market is by adopting a CI/CD practice and processes. It really enables us to rapidly develop these new features and services while maintaining system stability, reliability, and security. And as AWS is increasing, as we are increasing our pace of innovation, we've also provided tools to help enable customers and partners to increase their speed of innovation and help speed up their time to market for their applications as well. We have tools that we've released to help you go faster in a more stable way. And some of those examples are AWS CodeCommit, Code Pipeline, and CodeBuild. So let's talk about the release cycle. There are 4 major phases. The first one is the source phase. In general, the development code is stored in a version control repository. This could be something like CodeCommit or GitHub, and it's a location where the code is committed and then most likely peer reviewed. The source code can describe the application, but it also can describe the server infrastructure that the application will be deployed in. So not long ago, the code repository was only for the source code of an application, but with the advent of the cloud, the code base can also include the code that creates the server environment in which the application is launched. Next, we have the build phase. So this is where the code is checked out from the code repository and compiled if necessary, and then there are basic unit tests run against it. This artifact in the build process can be a compiled binary, but it also could be bundled source code, or it can be a container image. Next, we have the testing phase. This is where more in-depth functionality testing happens. For example, integration tests with other systems, possibly some static code analysis, load, penetration, and UI testing, those sorts of tests. And once the code passes those tests, we then can deploy that new code to production environments. So let's talk about the process levels for each of these major phases. First, we have continuous integration. So this is where we go through at least through the build phase with some basic automated testing on the applications. Continuous integration is the practice of checking in your code into a versioning repository continuously and then verifying each change with an automated build and test process. Continuous integration practices have made teams more productive, and it's allowed them to develop new features faster. The continuous integration requires teams to write automated tests, which, as we've learned, improve the quality of software being released, and it reduces time that it takes to validate that a new version of software is valid. So with continuous delivery, it extends the CI, the continuous integration, to include testing out to production-like phases and running verification tests against those deployments. But then there's some sort of, gating mechanism, like a manual intervention or a checkpoint between when the code has been tested and when it is available for customers to use in production. Continuous delivery is a really big step forward over continuous integration. It really allows teams to gain a greater level of certainty that their software will work once it's out and available to their customers. Some businesses actually need a gating mechanism for compliance reasons, and so they require a human to sign off on the build before deploying updates into production. And then we have continuous deployment. This is the holy grail of the CI/CD process. Continuous deployment extends continuous delivery and the automated release of software to customers from check-in through build and test and out to production without any human intervention. Many teams at Amazon have reached a continuous state of deployment. Continuous deployment just is a time for your customers to get the value from the code that your team has just written, with the team getting faster feedback on the changes that they've made. And this fast customer feedback loop really allows you to iterate quickly and allows you to deliver more valuable software to your customers quicker and more reliably. So at Amazon, we really strive very hard to get our teams to get here. It's quite challenging to get to this stage. It's both a technology and a process change. But the companies that go from high stakes deployments that would happen once every few weeks or maybe even few months can then iterate faster. They can get to tens or even thousands of deployments a day. So these are a few examples of some of the services that are available to customers running in AWS for their CI/CD process. For code services, we believe in customer choice. So customers can utilize different AWS services, but they can also bring their own tools into this process. We make it easy for them to plug in both AWS services as well as third-party tools into their CI/CD process. So first, for the source phase, we have CodeCommit here. So that's the AWS managed Git-based code repository service. This is one option for our customers. It's provided for those who want to use AWS for their end-to-end solution. We also have some partners like GitHub and Atlassian's Bitbucket that you can also use in this in the source phase. Then we have CodeBuild. This is an option for customers who want to use CodeBuild for their build process, but we also have tight integration with different partners such as Jenkins or Solana CI. And then for the test phase, we have some third-party tools. Some of those include, there are third-party tools available for customers, such as they can use their existing Jenkins instances, or they can use BlazeMeter or Apica, or other third-party tools in this phase. And then we have, for the production phase, there's Code Deploy. Code Deploy is a service that can be used to deploy new code on the production phase to EC2, but it can also deploy to on-premises servers. AWS also supports custom deployment for customers who want to build and manage their own deployment mechanisms. So let's talk about building and testing your applications and different platforms that you can use. So a common model our customers have for building and testing their applications is to use an EC2 instance for their build phase. Sometimes we find that companies and partners, they want to start with on-demand, as they don't have to do any capacity planning for their test and build environments, and they can just click and go. Once they end up understanding what their utilization will be, reserved instances is a great way for companies to find a significant discount, up to 75% compared to on-demand instance pricing. This is in exchange for a commitment to use the service for some period of time, either 1 to 3 years. And then finally, we have Spot. This is a pretty interesting consumption model. It works on a market basis. So the price fluctuates based on demand. So batch, transient, or time-sensitive workloads are really ideal for Spot usage. Spot enables you to bid on unused EC2 capacity. You're often able to launch instances on the cloud for savings as much as up to 90% of the equivalent on-demand rate. The trade-off for Spot is if other customers are willing to pay more for you for the same AWS instance type, or the capacity of that type has become constrained, your running jobs may be terminated. So jobs running on Spot, therefore, need to be fault tolerant and able to be restarted at a later time. Spot does allow you to grow your compute capacity and throughput for the same budget. So, for example, if you have an on-demand instance that's always running 24 hours a day, 7 days a week, you can launch a Spot instance that has greater compute capacity for something like a batch process within the same budget. Spot also integrates with other AWS services, such as Amazon VPC, Amazon Elastic MapReduce, AWS CloudFormation, as well as auto-scaling. So it makes it easy for you to incorporate these money-saving instances into your existing architectures. And many customers interact with Spot automatically or programmatically via the API, and it really helps them save money. So either way, if you aren't already, you should really experiment with Spot and save money and be a hero to your boss. Why use Spot? Lyft is a really great example. They found a savings of $15,000 a month with 4 lines of code. So after using Spot in their CI/CD environment, Lyft recognized the stability of the platform, and they found an opportunity to leverage it as part of their Hadoop stack that's run by Kubel. They've since shifted a third of their Kubel managed Hadoop cluster onto EC2 Spot, saving even further. So Spot is a great option to use if you have a Jenkins or a Bamboo environment because Spot is built right into it. Your worker node structure, even if it goes away, these jobs are restartable. So with this Jenkins plugins, you can add capacity for your build queues without needing to re-architect your build environment. The plugin uses what's called a Amazon Spot fleet to launch the instances instead of relying on the Jenkins server itself to directly launch these Spot instances. What Spot Fleet does is that it attempts to maintain the fleet's target capacity as Spot prices change to maintain the fleet within their specified price range. Continuous delivery with ECS to ECS with Jenkins. As you can see in this diagram, it fits really easily into your CI/CD workflow. So as many development teams move towards microservice architectures and containers, they're looking to easily integrate this new technology into their existing workflows. So building container images and deploying them to ECS is one of the integral opportunities with Jenkins. So as you can see from this diagram, the workflow is relatively straightforward. A developer committing code to a code repository triggers the build of a container image from source code onto Jenkins. After the image is created, Jenkins can run unit tests on the resulting image. And then once those tests have passed, Jenkins then pushes that Docker image to a registry, such as, in this example, it's the EC2 container registry. Once that push is complete, Jenkins then updates the service in ECS, which then pulls the latest image from the registry and starts a new container with the updated code base. Now we have the AWS CodeBuild service. AWS CodeBuild, this is an option for customers who don't want to manage their Jenkins server clusters or to worry about pricing for their Spot instances. AWS CodeBuild is a fully managed build service that removes the undifferentiated heavy lifting of provisioning and managing and scaling your own build servers. So with CodeBuild, you don't need to worry about installing software and maintaining it and keeping your build environment instances up to date with the latest packages. CodeBuild also scales up automatically to meet the builds of your development teams and to meet the needs of your build queues. So in addition, CodeBuild is an on-demand service. So it's where you pay as you go. You're charged based only on the number of minutes it takes for you to complete your build. Why use Amazon CodeBuild? These are some of the benefits that you get with it. So as I stated, it is a fully managed service. It eliminates the need for you to set up and patch and update and manage your own build servers and software. It also scales automatically to meet your build volume. It immediately processes each build you submit and can run separate builds concurrently, which means that your builds aren't left waiting in a build queue. You also don't have to figure out the capacity for your build cluster. Then you're also charged based on the number of minutes it takes to complete your build. So this means that you no longer have to worry about paying for idle build server capacity. And in addition to the pre-packaged build tools, it's easily extensible, so you can actually create your own build tools and build environment containing the build tools and programming runtimes that your build needs, creating custom build environments. You can also integrate CodeBuild into your existing CI/CD workflow. For example, you can use CodeBuild as a worker node for your existing Jenkins project for distributed builds. And finally, it's secure. We work hard here at Amazon in order to ensure the security of the platform. We see security as job zero. So your build artifacts are encrypted with customer-specific keys that are managed by the AWS Key Management Service. CodeBuild is also integrated with the AWS Identity and Access Management Service, so you can assign user-specific permissions to your build projects. So let's go over the process and how CodeBuild may fit in with your CI/CD process. A commit to a source code repository triggers a build. This build trigger then hands off the build job to CodeBuild. CodeBuild then processes and produces an artifact from the build. Such output artifacts can be a jar file for Java projects or even a Docker container image. It's easily pluggable, so you can incorporate it into your workflow by using the service API or using the command line. You can also bring your build environments, as I said before, so you can have your project-specific build tools. You can bring them to use in your CodeBuild project. It's also super simple to integrate with Jenkins. There's an open source plugin. This plugin allows you to easily integrate using CodeBuild into your Jenkins workflow. If you already have a Jenkins environment existing, you can utilize CodeBuild to add capacity to your builds, to your build environment. So when using CodeBuild for Jenkins, you'll need to tell CodeBuild, when using CodeBuild, you need to tell CodeBuild the steps that you want it to execute against your code base. To do so, you'll describe these steps in what's called a build spec file. This is just an example of a build spec file. So a build spec file has various sequences within it. So that you can provide it with environment variables that are specific to your build. You can, and then you can also define the phases within this within the file. So, for example, an install phase; those will be the commands that AWS CodeBuild will run during the installation. In this example, we'll be installing the Apache Maven package, which is a build automation tool that's used primarily for Java projects. There's a pre-build process. It's any command you want to run before the build. So, for example, if you're creating a Docker image and you want to commit it, if you want to push it to an ECR repository, you need to get those credentials before you're able to push that image. Then you have build. The build section details the commands that you will run during the build process. So in this case, we're going to be running a Maven install to compile a Java jar artifact. And then post-build, that's any action you want it to take after your build process is completed. So for example, this is where if you are building a Docker image, you can push it to ECR. And then finally, we have the artifact section. That represents information about where AWS CodeBuild will find the build output and how AWS CodeBuild will prepare it for uploading to the Amazon S3 output bucket. CodeBuild and Jenkins, it makes for happy development teams. So let's see how it can easily fit into your Jenkins workflow. So a development team commits to the code repository, and in this case, it's AWS CodeCommit, but it can be another code repository such as GitHub or Bitbucket. So these changes to the code base trigger the Jenkins project that is associated with the code base. Jenkins then kicks off the build process in AWS CodeBuild. Using the build spec file, CodeBuild then executes the command specified in the file and creates an output artifact. This output artifact is then uploaded to S3, and any log messages or errors from the build in AWS CodeBuild are displayed on the console, but they are also available in Amazon CloudWatch. So let's make your life simpler. Jenkins Master manages the project and the build queue, and then it can hand the build work off to the worker nodes. So these worker nodes can be EC2 spot instances, but it can also hand that work off to AWS CodeBuild. Okay, and let me show you a pre-recorded demo that I have that shows you how easy it is to set up a Jenkins project to use AWS CodeBuild for your build process. So here we have a simple demo web app that's stored in an S3 bucket. It shows the information of the system that it's running on. So for example, there's a system overview. Get rid of that, there we go. CPU information, RAM information, etc. So let's go to CodeBuild and see how the CodeBuild project is configured. So I'll just edit this project. You can see the project name, Jenkins CodeBuild Demo. You'll need to use that when you're setting up your Jenkins project. The source code will be a CodeCommit repository called CodeBuild Jenkins Demo. We're using the Python image for the build, and we are also using a build spec file that is in the root directory of the source code in the code repository. This output artifact, we're going to have AWS CodeBuild push the build artifact to Amazon S3 to a bucket called Jenkins CodeBuild Demo. And we've created a service rule for AWS CodeBuild to allow it to interact with the necessary AWS services, such as CodeCommit or Amazon S3 on your behalf. All right, and let's look at the project that's associated with the code base and see how it's set up. So you can see the project name. We set the source code repository to be the same repository as the one that we defined in the CodeBuild configuration. And we set the build trigger to pull the code repository for changes every minute. So it will pick up the changes as soon as they are pushed to, as they are recognized in the code repository. For the build phase, we chose AWS CodeBuild. And we've entered the AWS access and secret keys that we have created specifically for this Jenkins server. It enables it to programmatically interact with AWS CodeBuild and CodeCommit services. As you can see, that project name is the same project name as the one that we defined in AWS CodeBuild. All right, now let's look at the build spec file that I've created. It's a pretty simple build spec file. It really only has post-build commands. First, it lists the files within the CodeBuild source directory. And then it lists the objects that are in the S3 bucket. And then it does an AWS S3 sync, which syncs the files in the source directory on CodeBuild directory www, and then syncs them up to the S3 bucket. Now I'm just going to edit the index.html file so I'm going to edit it so that we can commit those changes and then push them to the code repository. I'm going to update this title to be Jenkins Demo Web App. Then I'm going to change some of the other titles within the web app. Okay, great. Now I'm going to commit those changes to the local Git repository with a comment that they're more descriptive titles. Okay, and now I'm going to push those changes to the CodeCommit repository. All right, now let's go back to the Jenkins project. The Jenkins project should automatically detect that there have been changes pushed to the repository and then initiate a build accordingly. Oh, there it goes. So it just recognized that those changes have been committed and a build has started. So let's click on the build number and then go to the console output. Right, and as you can see, it's already handed that build job over to the CodeBuild project. We'll refresh this so that we can see the progress. There we go, the build is running. And we'll just click on the build run to get more details of the status of the build. So now it's downloading the source code from the code repository. Oh, and now it is on the post-build. So it's done the listing of the files within the CodeBuild source directory. Now it's listing the S3 objects, and it has done the AWS S3 sync from the www directory into the S3 bucket. It's successful. It's completed as successful, and the Jenkins project has also seen that the build as successful. So we'll refresh the app and we can already see the update. They've already been pushed out to the production S3 bucket. All of my very descriptive names for the titles are now in the application. So thank you for joining us today. If you'd like to learn more about AWS CodeBuild, please go to the CodeBuild service page at aws.amazon.com/CodeBuild. Thank you.
Great. Thank you, Aaron, for a great presentation. And I would like to thank the moderators for answering as many of the audience questions as they were able to get to. On your screen, you will see a few polls. Please take a quick minute to provide us with your feedback when you see these poll questions appear on your screen. And again, we are recording today's session. In the next few days, we will send you a follow-up email with a link to the slides and the recording. We're going to hang out for another few minutes and continue to answer any questions through the Q&A window, so please ask any final questions, and we'll try to get to as many of those as we can. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS will cover in future webinars, please drop us a line at aws-webcast@amazon.com. Your feedback will help us to improve our webinar programming. Thank you to the audience for taking the time to join us today. Please enjoy the rest of your day.